Hi, this is going to be kind of a long lecture, and I'm going to do it different from before. I'm not going to provide notes, so I'll give time for you to write your own notes. So this is lecture 3.8. I'm actually going to be on my living room floor to get this done. So this is 3.8 lecture for 135. We're going to look at optimization problems. Optimization problems, and we'll have a little project to do as well, but not yet. Okay, so let's start off. Let's say we're given a 3,600 foot of fencing. Okay, what is the largest area of a three-sided enclosure? Also, what are the dimensions? Okay, we have 3,600 foot of fencing. What is the largest area of a three-sided enclosure? Also, what are the dimensions? Okay, so we're not sure. Let's just draw little pictures. Here we have fence, and here's a building. We could make it look like that, or we could make it skinnier and look like that. We don't know what it looks like, right? To make the largest area. So we have to just go and use our variables and figure it out. Okay. What we do know is the total fence is 3,600 feet. So let's draw a picture. Here's the wall. Here's the fence. All right, we don't know the length of these two sides, but we know they're the same. So we're going to call those X. Now this whole thing is 3,600 feet. So this piece right here is going to be 3,600 minus 2x, because we're going to take away these two pieces to get this left over. All right. What we also know is area equals length times width. Okay. So the area that we're looking at right now is going to be this length, which is 3,600 minus 2x, and then we're going to multiply that by the width, which is x. Okay, so let's go ahead and multiply that out, and we're going to call this a of x equals 3,600x minus 2x squared. All right. So next we're going to find the critical numbers, because we're looking for optimization. We're looking for the maximum area. So we're going to take a prime of x. All right. A prime of x. This is just 3,600 minus 4x. Okay. Now what we do to look for our max or our min, in this case going to be a max, we set it to 0. 3,600 minus 4x. So we solve. We're going to add 4x to both sides. All right, so x is going to equal 900. Now what we found here is a critical number. Okay. All right, I'm going to erase this, give you a moment. All right, so what are we going to do with that critical number? Let's continue. I'm going to erase all this right here. Okay, well, we're going to look at a double prime x. Okay, a double prime x is going to be -4. -4 is less than 0. So what do we know? We know it concaves down. So at x equals 900, we have a relative max. Okay, so before we had stated that a of x equals 3600 minus 2x squared. All right, so now we can put in 900, a of 900. Okay, and what we end up with is 1,620,000 feet squared. All right, so that'll be our maximum area. And now we want to know what the dimensions are. Well, we already know that one of them is 900. So what's the second one? Well, originally we had said the length equals 3600 minus 2x. So we're going to put in 900 there. 2 times 900. And that equals 1,800 feet. So the dimensions are 1,800 feet by 900 feet.